Welcome to Water Supply and Wastewater Engineering course. So today we'll be discussing Unit 3, that is which is started long back, that is unit processes in the municipal water treatment plant, and this will be the last lecture in the Unit 3, that is disinfection. So let's get started. So just give me a brief introduction of this disinfection or total entire water treatment plant. So what we have discussed till now in this unit 3, or as of now in the water supply and wastewater engineering. So first step is basically we are collecting the water from the river or any water source, raw water source. So once water is collected, it comes to the water treatment plant. So in the water treatment plant, the first step what we do, water will pass through the screening, right? Screening. So in the screening, basically it is a grid, something grid will be there, steel grids will be there. In that each steel grid water will pass through, and the floating object which is present in the water will be retained in by the steel grid. So this initially screening will be there. Once the floating objects everything is removed from the water, then water will come to first chamber, we call it aeration tank, right? We have discussed in details all these topics. So once water is into aeration tank, so this is aeration tank. So once water is in the aeration tank, after so we remove the gases present in the dissolved gases present in the water, as well as the oxygen has been added into the water. Then water will go to primary sedimentation tank. So that this tank is basically primary sedimentation tank anyway. So this is the primary sedimentation tank. So after primary sedimentation tank, water will go to coagulation and flocculation tank, where do we add the chemicals to the water. So once we add the chemical, water will go to next step, that is we call it secondary sedimentation tank. Okay, so water will go to secondary sedimentation tank. Here all the suspended particles will be removed in the secondary sedimentation tank. Next water will go to filtration. Okay, so filtration. So here also we have seen in details there are two types of filter, that is rapid send filter and slow send filter. So in the filtration step, basically even all the particles like which are present in the suspended particles which are present in the water, and all these solid particles will be removed in the filtration step. So after filtration step, the last step will be water will go to disinfection. So today we'll be discussing disinfection, this last step. So once disinfection is done, means in this step basically we are killing the germs, bacteria, pathogenic bacteria which are present in the water. So once that is cleaned or that is removed, then water will go for the distribution of the household. So okay, so then it will go to distribution system. This is the entire flow chart of the water treatment plant. So each topic we have discussed in details, one or two lectures has been devoted in the each topic, each unit, and we have seen couple of problems also, like design of primary sedimentation tank, design of secondary sedimentation tank, design of rapid send filter. All these numerical problems also we have solved. So please go through all the earlier previous lectures and make your understanding clear. So disinfection, as I mentioned, this is the last step before we supply the water into the household. So the filtered water may normally contain some harmful diseases, producing bacteria in it. So we have removed all the solid particles which is present in the water, but still the bacteria and the fine viruses will be present in the water. Even in the filtration process also we have removed the few bacteria definitely, but still the bacteria and viruses, pathogenic bacteria, viruses still present in the water, that will be removing here. So this virus must be killed in order to make the water safe for drinking. So the process of killing these bacteria are known as basically disinfection or the sterilization. So disinfection kinematics. So how actually disinfection happens in the water? So when a single unit of microorganisms is exposed to the single unit of the disinfectant, the reduction in microorganism follows the first order reaction. So what is happening? So initially you have the N naught. So N naught is the initially you have that much quantity of bacteria present in the water. So what will happen? So this is this type of curve it will follow. So what is this curve? So this is time, and this is the concentration of bacteria or virus or microorganism basically. So what will happen, if you see, as long as time passes, the initially the microorganism was more, but as long as time passes the microorganism number is reduced, right? Because the more reaction will be happening with the disinfectant and the microorganisms will be killed. So this is the equation it follows. So n equal to n is the concentration of microorganism, which is equal to n naught. N naught is initially how much it was, into e to the power minus kt. So if you take the derivative, because it is a time, if you take the derivative, so this is the equation, you got it right. So this is the plot basically. If you plot this equation, this is the graph, you will get it. So the equation we call it, this is the Chick's law here, this equation, and the n naught is the number of microorganisms, initial number, k is the disinfectant constant. So we use some chemicals, right, for the disinfection purpose. So disinfection constant will be will be changing depending on which type of chemical we use. So depending on the chemicals, this values k value will be will be chosen, and t is the contact time, means how much time the reaction takes place. So this is the contact time. Okay, so this is the actual kinematics happening, disinfection kinematics happening in the water. So now the method of disinfections, how disinfection is done. So now if you if you visit any rural areas, so they don't have the sophisticated water treatment plants, so what they will do. So what rural people will do, normally they collect the water from the river stream which is passing through, or maybe a lake, and and they keep it, they make a homemade filter. So in the homemade filter, if you see, they keep different layers, like at the top you have this big gravel type things will be there, right, and then here you have this fine gravels, then at the bottom they keep the sand. So here you have the sand, and then they are collecting the water from the bottom. So this is the homemade filter, normally in the rural areas, or in the earlier centuries, people used to make the rural homemade filters. So in that also, if the principle is same what we are doing in water treatment class, so we are doing it in larger scale, because we have to distribute the water for the entire city or the industries nearby. But in the earlier rural areas, basically, even in the rural areas nowadays, this type of filters they use. So basically they collect the water from the river stream, and they keep the water at the top of this filter. So this is a small filter. Here at the top you have the big gravels. So in the big gravels, basically all the large particles, floating particles, and all the large particles will be simply retained in this gravel, right. Then the filtered water will go to here the fine gravels they keep. So in the fine gravel also, the fine particles, solid particles also will be retained in this layer. Then in the last layer they keep the sand, the fine sand. Even in the even in the that filtration, what we do similar thing here, they keep the filtration, that fine sand. So after fine sand, all the suspended particles also will be removed, and you will get the crystal clear water at the bottom. So this is the homemade water treatment plant, which normally earlier even in the rural areas also they construct similar thing. So now in this water also, what they will do, now after they collect the water, so this water is cleared from any solid particles. So now the still the virus bacteria are present in the water, right, that has to be removed. So how they do in the rural areas, simply they boil the water. So once you boil the water, what will happen, the temperature of the water will increase, right. So at that point, the which the virus and bacteria which are present in the water, that cannot survive, because the temperature is very high and it will get killed. So the boiling is a technique basically where you can kill those present bacteria. So disinfection, so these are different methods of disinfection. So the first step is boiling. So boiling is possible maybe in a small scale for the house purpose, where we for the house purpose, we can use the boiling technique as a disinfection. But for the rural, for the urban cities like Hyderabad or any municipal corporations, here the water demand is very high. So boiling is not a practical solution for the big, for the large cities. So the bacteria present in the water can be destroyed by boiling in it for the long time. However, it is not practically possible, right, because huge amount of water you cannot boil it. So moreover, it cannot take care about the future possible contamination. Now what will happen, even if you boil the water, so the bacteria will be removed, right. Now the water will be distributed to the entire household. So while distributing, that is pipes basically, that water pipes we are laying down on the ground. So here also, if any leakage or anything happens, what will happen, so the virus bacteria will go into the water. So that still the bacteria, the virus will be there in the water, right. So boiling is not a good ideal idea, alternative for the disinfection. So the second option, we see the treatment with the excess lime. So lime is used in the water treatment plant for the softening purpose. Softening purpose we use this lime, right? But if excess lime is added into the water, it can in addition kill the extreme, it can also kill the bacteria, right? When limes are added, the pH value of the water, will be increased. The water will be extremely alkaline. So the extreme alkalinity has been found detrimental to survival of bacteria. So in the high alkaline water, the bacteria cannot survive. So this is another way you can add the excess lime into the water, so the entire, the water will be disinfected, because again the alkalinity of the water will be increased. So somehow you have to remove the excess lime from the water before you distribute it into the general public. So the treatment like recarbonation from for the lime removal should be used after disinfection. So once if you use the excess lime into the water, what will happen? The alkalinity of the water will increase, right? So although the virus bacteria will be removed, but the alkalinity will be very high. So before you distribute the water into the household, we have to make sure that the alkalinity has been removed before we distribute it. So this is the second option. The third option is treatment with ozone. So this is very much effective treatment method. So ozone is basically basically when it come in contact with the water, basically it decomposes and the oxygen will be removed, right? So the oxygen, so ozone will readily break down into the normal oxygen and releases the that you know releases this activated oxygen, we call it. So this activated oxygen is basically powerful in oxidizing the agent and removes the organic matter which is present in the water, that is the virus bacteria which are present in the water. So ozone is very good in treating the water for the disinfection purpose. That's why if you see now in nowadays in the this electronic water purifier system which we install in our home, there sometimes it will mention that ozone, with ozone treatment, they'll mention in the advertisement. So basically ozone is a very good very good disinfection. So again, for the large scale, the ozone use, the cost of cleaning of water will be again very high. So for the large cities where the water, more quantity of water has to be treated, in that case the ozone maybe some expensive in that case. Now the last or fourth method for disinfection is the chlorination. So this is the most maximum location or maximum water treatment plant we use this chlorination. So the germicidal action of chlorine is explained by the recent theory of this hypothesis, according to which the chlorine enters into the cell of the bacteria and kill the enzyme which is essential for the metabolic process of living organisms. So basically what will happen, chlorine enters into the cell of this bacteria and the viruses and kill the enzyme which is basically essential. That is, the chlorination is very much useful, and nowadays even in rural areas also sometimes they use the chlorination in form of that bleaching powder is there. And bleaching powder is made up of chlorine compound only. So they are also made, very high quantity of chlorine is available in the bleaching powder. So bleaching powder is one of the uh, you know uh, disinfectant which is used for the removal of virus and bacteria. So the chlorine chemistry, as I mentioned, chlorine nature is mostly mostly used in India as well as in the rural part of India as well. So the chlorination chemistry, what is happened? So when you add the chlorine, so chlorine is added into the water, either it form, in a form of salt, basically that, and what I spoke about, and the bleaching powder. So bleaching powder is also added in a salt. It is in a powder fashion into the water. So the, or sometimes some gas form also chlorine we can add it into the water. So however it can also add it as a salt, such as the sodium hypochlorite, that NaOCl, which is, we call it bleaching powder, right? NaOCl, please remember this equation. So the formula, basically the bleaching powder formula. So the chlorine like gas dissolves in the water in the following equation. So chlorine, if you add it into the water as a gaseous form, it will be dissolved into the oxygen, so Cl2 aqua form, basically. Okay, so this is the reaction takes place initially. Now the once the chlorine is dissolved into the water, okay, then it will take it will have the reaction with the water, and it will create that hypochlorous acid, HOCl plus H plus Cl minus. So this reaction will be taking place. This is the chlorine which we added into the water, and it will be reacting with the water, and this HOCl, that is hypochlorous acid, will form, right? So this hypochlorous acid is actually very weak, and it will be Cl minus and H plus, that it also will dissolve. HCl also will dissolve into the water, that is hypochlorite ion, it will convert OCl minus and H plus. This reaction will takes place. So the all form of chlorine are actually measured in milligram per liter. So always we refer how much chlorine we added, that is milligram per liter of chlorine. That's what we call it. Okay, so chlorine is present in a different form into the water, right? So the hypochlorite, the hypochlorous acid, hypochlorite ion, so in many form it will be there. So hypochlorous acid and hypochlorite ion composes what we call it free chlorine residuals, right? So now you saw how this hypochlorous acid and hypochlorite ion is formed, right? This we call it actually free residual. So this free chlorine compound can react with the mainly organic and inorganic compound to form the chlorinated compound, right? In the water, there are organic and inorganic present, material compound will be there, virus bacteria will be there. So we'll react with the organic inorganic compounds and it will form the chlorinated compound. So if the product of this reaction possibly oxidation potential, they are considered to be as a chlorine residence. So a common compound which is present will be reacting with the ammonium which is present into the water, and it will form the monochloromanite. So monochloramine is the N2 NH2Cl. So this is the compound it will form, and some compound also dichloroamine. So the chlorine will react with the amine, so ammonia basically, and it will form this NH2Cl, NHCl2, and trichloramine, that is NCl3. So these three compound basically it will form. So the chlorine which is present in the water, now you understand, it will form in these three component. So this monochloramine, this is the compound which is actually very useful for the disinfection purpose. So many drinking water utilities uses this monochloramine. So this monochloramine is very much useful for the disinfection. So this will go enter into the virus bacteria cell and it will destroy the virus and bacteria. So if excess chlorine is if excess free chlorine exceeds once all the ammonium nitrogen has been converted into the monochloramine, so all the once the conversion is takes place, the chloroaramine basically happens. So this is the reaction you can see. So HOCl, which is formed in the last slide you have seen, which will react with the ammonia present in the water, and NH2Cl, that is the monochloramine, will form, plus HOCl also will form, right? So this reaction will takes place, and this is the agent which is responsible for disinfection properties of water. So you can see another very important parameter is the breakpoint reaction. So what will happen now if you add excess amount of free chlorine into the water? So once you add any excess amount of chlorine, then more quantity of HCl will be present in the water. That will react to the monochloramine which is formed in the earlier step you have seen, and it will remove. So this reaction will takes place. So this is the chart. If you see, initially if you add the small quantity of chlorine, then whatever ammonium present in the water, that will get NH2Cl. This reaction will take place, right? After certain point, if you add more quantity of chlorine, so all the all the ammonias will be converted into NH2Cl. Then again if you add more quantity of chlorine also, so that chlorine will be present in the water as a free chlorine, because all the ammonium which is present in the water, that already got converted into NH2Cl, right? So now the extra, if you add more, that we call it free chlorine. So that will be still present in the water. So free chlorine, why it is important? So always we have to keep some quantity of free chlorine present in the water. Why? Because once we distribute the water from from the water treatment plant to the household of a city, so in that case, while transporting the water there, if there is any leakage in the pipe system, right, so in that case the virus bacteria will be present in the enter into the water. So if you have some extra free chlorine, so that will basically again kill those bacteria, and water will be again safe for drinking. So now this is the very much important graph. So from this graph basically we find out how much chlorine or how much bleaching powder has to be added, or how much chlorine has to be added into the water to kill this bacteria. So this type of plots basically we make. So this is the plot. This axis you can see residual chlorine versus initial ammonium. So initial, how much ammonia is present in the water, and the residual chlorine. So this is the ratio, and here also the chlorine dosage means how much chlorine we give into the water, and also the initial ammonia, how much is present. So with this basically this type of plot we got it. So at this point we finalize how much chlorine dosage is very much useful for the for the treatment. So the formation of chloroamine and the breakpoint reaction creates a unit relation between the chlorine dosage and the amount and the form of chlorine as illustrated below. So here you can see you have the free chlorine. Free chlorine is if you add more quantity of chlorine, and this is very much important. And you have the chloramine. Chloramine is also responsible for the disinfection, right? So that compound is basically kills the bacteria and all. And ammonium nitrogen reaction, of how much it will take place. So this is very much a good reaction, breakdown point reaction, where we find it out the chlorine dosage, means how much quantity of chlorine is we have to add it. So now the chlorine demand. So free chlorine and chloroamine readily reacts with the variety of component, includes organic substance. So these are the present in the water, right? Chloroamine and also the free chlorine. So these will react with the organic substances like iron, manganese, which is present in the water, right? So these are the reactions it will takes place. So also the chlorine demand can be increased by the oxidation reaction with the inorganic compound. So these are the oxidation reactions take place. So again, this reaction is not that much important, but still you can go through the each reactions how this chlorine will react with the other magnesium, other manganese, and other iron compounds present in the water. So that is the actual process which is happening. So in this lecture, what we have seen is a very good, very important parameter in the water treatment plant. It is the disinfection. So disinfection is basically the process where we kill those pathogenic bacteria present in the water. So here we have seen the different methods of the disinfection. Like first one is the boiling of water. Boiling of water is again not useful for the large water treatment plant. So again we have seen with this ozone treatment is also there for the small scale in household. We can do it ozone, which is very effective in that sense. But again, the cost of pure water treatment will be again increasing if we use ozone. So now lastly we have seen the chlorination, which is most widely used in the rural areas as well as the municipal corporations also, where we add the chlorine compound into the water, either in form of bleaching powder or any other form we add into the water. So this will react with the water and it will form the hypochlorous acid, and from hypochlorous acid it will react with the ammonia present in the water, and it forms the monochloroamine compound that will basically act as a disinfectant, and it will kill those pathogenic bacteria present in the water. So now our water is clean. We removed initially all the solid particles, and in the last step we removed the bacteria, the virus present in the water. Now our water is safe for drinking, and we have now water will be distributed into the entire household. So in this lecture we are completing this unit number 3, that is unit processes in the water treatment plant. So in the next unit, that is unit 4, we'll be discussing about now all the units, how we can place it on a water treatment plant, and then subsequently we'll discuss how to distribute the water into the household. Thank you.